sklearnpreprocessingKernelCenterer. Description: KernelCenterer is a class in scikit-learn sklearn used for centering kernel matrices. It is specifically used in kernel-based machine learning methods, such as kernel ridge regression or support vector machines, to ensure that the kernel matrix has a zero mean. This centering step is crucial for improving the performance of these algorithms. Inputs: X, a NumPy array representing the kernel matrix. The kernel matrix is a square matrix where each element represents the similarity between two data points. Outputs: K, the centered kernel matrix. X fit the original kernel matrix, but modified in place. This is useful for chained transformations. Steps: Calculate the mean of each row of the kernel matrix. Subtract the mean of each row from the corresponding row of the kernel matrix. Calculate the mean of each column of the kernel matrix. Subtract the mean of each column from the corresponding column of the kernel matrix. Adjust the diagonal elements of the kernel matrix to compensate for the centering operations. Metrics: Non-KernelCenterer itself does not directly produce metrics. It is a preprocessing step that prepares data for further analysis. Visualization plots: Non-KernelCenterer does not generate visualization plots. Its primary purpose is to transform data for other machine learning algorithms. Fine-tune parameters: Non-KernelCenterer does not have any tunable parameters. Uncertainty methods: Non-KernelCenterer is deterministic and does not involve any uncertainty estimation. Challenges and fixes: Challenge 1: The input data should be a valid kernel matrix, meaning it should be square and symmetric. Sample use case that resulted in challenge 1 providing a non-square or non-symmetric matrix as input. Fixes to challenge 1: Ensure that the input data is a valid kernel matrix before using KernelCenterer. Challenge 2: KernelCenterer assumes that the input kernel matrix is already calculated. Sample use case that resulted in challenge 2: Trying to use KernelCenterer directly on raw data, without first computing the kernel matrix. Fixes to challenge 2: Use an appropriate kernel function to compute the kernel matrix from the raw data before applying KernelCenterer.